Much more than just a sophisticated graphing calculator, MapleLearn enables students to solve problems line by line just as they would in their notebook. They can check individual steps as well as the final result, perform side calculations, and easily share their work with their teacher, tutor, or classmates if they need help. For instructors, MapleLearn provides an engaging demonstration environment that supports illuminating graphs, the ability to work through examples using a combination of manual steps and computations performed by MapleLearn, and easy parameterization of expressions for exploration of concepts. MapleLearn is an online product. All you need is an internet connection and a browser. MapleLearn will work on desktop computers, laptops, Chromebooks, and tablets. This is the MapleLearn interface accessed via Chrome. With MapleLearn, the full workspace is available to you. Math in MapleLearn is organized into groups. You can add text and plots to your groups and move your groups anywhere on the page, allowing you to treat the page as you would a piece of paper. We did this to mimic how students work in their notebook. The plot window to your right automatically updates as you click through a group, showing you only the graphs for the expressions within that group. Plots appear in the plot window as soon as the expression is entered. There's no need for commands. You can embed the plot directly into your group with a click of a button. And you can add text to a group to help document your work. In addition to plotting, MapleLearn makes it easy to parameterize an expression, helping you to develop an intuitive understanding of what those parameters actually do. Let's look at another example. In this example, we want to explore how each parameter affects the graph of the transform function g of x as compared to the original function, f of x. All it takes is a click of a button to create sliders that control the values of the parameters in the expression. Now we can move the sliders instantly to see how the graph is affected by each parameter. You can ask MapleLearn to show you any special points on the graph, such as the x-intercepts and y-intercepts, by clicking the Special Points button in the bottom. Now, sliders are not only for exploring graphs, they can be used to see how results change as you modify an input, as can be seen in this example. In this example, we can use the slider to see the effects of changing initial velocity on the stopping time. We could also parameterize the acceleration variable if we wanted to explore the inverse relationship between acceleration and time. Let's look at another example. One of the most compelling features of MapleLearn is the flexibility it gives you over how you solve a problem. MapleLearn lets you go straight to the answer so you quickly perform steps that are already well understood, or work out your problem step by step. You can even use a combination of manual steps and steps you ask MapleLearn to perform in order to solve your problem. Now, this is a worked out problem completed by a student using MapleLearn. It was sent to me via the share link in MapleLearn. Students can use the share link to share the document with their classmates, tutors, or instructors when they need help. And instructors, they can use it to share lessons, provide fully worked solutions to sample problems, set up interactive demonstrations, and give homework questions. So in this case, the student is asking for help. Let's see how the student could have used MapleLearn to diagnose where they went wrong. So it looks like the student set up the equations correctly. And based on these equations, the solution for x is minus 15 and 13. Now let's go ahead and find out what the solution is for y. I'm going to split these into two cases. And I can see that when x is equal to minus 15, y is minus 13. And similarly, when x is equal to 13, y is equal to 15. So now that we have the result, let's see if the student made a mistake in their main derivation or their factoring side calculation. Now, just by looking at the main derivation, I can tell the student made a mistake expanding the expression. But let's confirm using the context panel. So here's the mistake. Now, the student could have easily done the same diagnosis that we did, but sometimes it's nice, especially when you're feeling frustrated, to call up for help. Now, as you've seen, entering an expression in MapleLearn is fairly straightforward. However, if you have a large matrix or a complicated expression, you can take a picture of it using the free Maple Calculator app and bring it straight into MapleLearn, ready to go. So in this next example, I'm going to click on the Cloud Expressions button to retrieve a matrix that I've captured via the Maple Calculator. Once the expression is in MapleLearn, I can begin the task of transforming the matrix to reduced row echelon form, taking the determinant, or even finding the inverse. Now, MapleLearn includes a number of examples to help you get started. You can look at them by clicking on this Examples tab. So here's an example on how you can use MapleLearn to explore the concept of lines. Here's another one that's interactive that allows you to explore the concept of Taylor expansion. And if you have questions or run into issues, you can let us know directly through the product over here or via the feedback form on the MapleLearn website. Go to Help, About, and you can provide feedback. We hope you'll give it a try and be sure to let us know what you think.